Welcome to YCAD Wonders. I am Ganesh from Bangalore. Okay, in the last video, we saw what factors, multiples and prime numbers are. Okay, in this video, we will discuss prime factors, HCF and LCM. Okay, in the last video we saw how to find factors. So we know factors of 18 are 1, 2, 3, 6, 9, 18. So these are the factors of 18. Okay, what are the prime factors of 18? What are the prime numbers out of these 6? The prime numbers are prime factor. They are called prime factors. So prime factors of 18 are 2, 3, yeah, that's all, 2 and 3, isn't it? So other than 2 and 3, all other factors are other factors are not prime. See, 1 is neither prime nor composite, and 6, 9, 18 are composite numbers. They are not prime. Okay. Actually, any number can be written as a product of prime factors. For example, 18. How to write 18? As product of 2 and 3. So it can be written as 2 into 3 into 3, isn't it? So like this, any number can be written as a product of prime factors. This can be, in short, so this can be written as 2 into, see, 3 into 3 can be written as 3 square. Okay, in general, say A into A into A is what? A cube. Okay, so 5 into 5 into 5 into 5 is 5 power 4 and so on. Okay, now how to prime factor, how to write any number as a product of prime factors. Okay, let's take this 18 itself. Okay, let's divide 18 by any prime number. So by which prime number it's divisible? It's divisible by 2. Okay, let's divide by 2 and we get 9. Okay, now 9 is divisible by, it's not divisible by 2, but we can divide by 3, which is prime number. So 3 times, so again 3. So keep dividing till we get the remainder of, okay, till we get a factor of 1. Okay, so 3, when you divide 3 by 3, we get 1. Okay. Now, see, what are the prime factors, so by which we divided this? What are the prime factors involved in this division? Okay, these 3, correct, 2, 3 and 3. So therefore 18 can be written as 18 equal to 2 into 3 into 3. 3 into 3 is 3 square. Okay, so this is how we get this same. So any number can be written as product of prime factors. Okay, let's take say 72. Okay, this one. Yeah, this is an even number, so it's divisible by 2. So 36. You can divide this by 2, we get 18. This is divisible further by 2, so it's 9. It's divisible by 3, so it's 3 times 3 into 3 9, then 3 1. Okay. So now therefore 72 can be written as, so how many times this 2 occurs? 3 times, and 3 2 times. So you can write 72 as 2 power 3 or 2 cube into 3 square. Okay, like this any number can be written as a product of prime factors. Okay, we know what prime numbers are. We saw it in the last video. Okay, there is something called the coprime. So coprime, what are coprime numbers? So coprime numbers is a pair of numbers that don't have any common prime factor. Okay, if, let's take this say these two, 18 and 72. So 18 72. So here say prime factor, what are the prime factors of say 18? So prime factors of 18 2 and 3. So similarly for 72 also 2 and 3. So they have common prime factors, isn't it? That means this is not this pair is not a coprime pair, or these two numbers are not coprime. Okay, let's take any two prime numbers. So obviously they will not have any common prime factors. Say for example 2 and 7. So here there's no. So what are the prime factors of 2? Only 2. Prime factors of 7 only 7. They don't have any common prime factor. So no prime factor is common to both of these two numbers. Therefore, okay, this is coprime. But to be coprime numbers, see individually, say they need not be prime. So for example, even 4 and 7, let's say. So here 4 is not prime, but 7 is prime. But they don't have any common prime factor. Therefore, so this is a coprime pair. This coprime. So here one of them, say one of the numbers is prime, other one is not prime. Okay. Okay, but let's take this 4 and 15. So what are the factors of prime factors of 4? Because 4 is 2 square or 2 into 2, so prime factors. So 4 has only 2 as a prime factor, and 15 as the prime factors of 3 and 5. So that means there is no common prime factor, isn't it? There is no common prime factor. So therefore, this is also coprime. So here both the numbers are not prime. both are composite numbers, but still they form a co-prime pair, but they don't have any common prime factor. Fine. So we have now. So I hope it's clear what the co-prime numbers are. It's a pair of numbers that don't have any common prime factor. Okay, now let's see what how to find HCF, okay, and LCM of two numbers. So if the two numbers are co-prime numbers, okay, like any of these, let's say 4, 7 are 4 and 15, 4, 7 are 2, 7. So HCF of 4 and 15. Okay, if they don't have, if they are co-prime numbers, that means they don't have any common prime factor. That means HCF is 1. So similarly, HCF of 2 and 7 also 1. HCF of 4 and 7 is 1. Okay, this can HCF of this can be written as HCF of 4 comma 15. So that's why is equal to 1. Okay, similarly HCF of 2 and 7 is 1. HCF of 4 and 7 is 1. Okay. So suppose the two numbers are not co-prime. So not co-prime. Okay, let's assume one is so here let's say 4 and 12. So here one is the factor of other one, or one is a multiple of another one. So here 4 is a factor of 12 and or we can say 12 is a multiple of 4. So in that case, so bigger number is the HC. Okay, let's okay. So here a smaller number is the HCF. So for this HCF is 4 and bigger number is the LCM. So for these two numbers 4 and 12, so LCM is 12. So if one is a factor of another one or one is a multiple of other one, then HCF is the smaller number and LCM is the bigger one. Okay, in the case of co-prime numbers, take any of these 4 and 15, 2 and 7 or 4 and 7. Okay, so LCM will be, so for example LCM of 4 and 15. So in this case LCM will be with the co-prime numbers, LCM will be product of these two numbers. So LCM is equal to 4 into 15, so which is 60. Similarly, LCM of 4 and 7 is 4 into 7, 28, and LCM of 2 and 7 is 2 into 7, 14, because they are co-prime numbers. Okay, so this way you can easily find out, see if the two numbers are co-prime numbers, or say one of the numbers is a multiple or a factor of another one, then it's easy to find HCF and LCM. So you can use this method. Okay, let's consider numbers of different type. Okay, let's take 4 and 6. Okay. So here, so they are not co-prime. 4 and 6 are not co-prime because both have a common prime factor of 2. So because 2 is a common prime factor of both of these numbers, so they are not co-prime. Also, one is not a multiple or a factor of another one, because 4 is not a factor of 6 and 6 is not a multiple of 4. Okay, so in that case, so how to find HCF and LCM? Okay. So now there are different ways of finding. So one is one way you can list all the factors. What are the factors of 4? It's 1, 2, 4. What are the factors of 6? 1, 2, 3, 6. Okay. So what are the common factors? So common factors are, see 2 is there in both, correct. So common factor. Any other common factor? 1, because 1 will be common factor of any two numbers, so ignore 1. So common factors, or if you want to write, of course 1 will be there, all of them. So 1 also common. So common factors of 1 and 2. So no other factors are common to both 4 and 6. So these are common factors. Now HCF meaning highest common factor. Out of this, which is highest? 2. 2 is highest. Therefore, HCF of 4 and 6 is 2. Okay. So now LCM. So how to find a LCM of this? So for LCM you require multiple. Say what is LCM? LCM means least common multiple or lowest common multiple. So 4 and 6. So for example, we need to for this we need to find the all multiples of 4. What are the multiples of 4? 4, 8, 12, 16, 20, 24 and so on. So what are the multiples of 6? 6 into 2, 12, 6 into 3, 18, 24 and so on, 30. Okay, now what are common multiples? So common multiples, see here 12 is common, then say 24 also. So common multiples are so there are many common multiples, but so it goes like this, say 12, 24 and so on, correct. So what is the smallest? LCM is what? Least or lowest or smallest common multiple. So LCM is 12. Okay, so this is one way of finding HCF and LCM. But there are, if there are numbers are big, it will be difficult to find. So list all the factors and find the HCF, or list all the multiples and find the LCM. Okay, so there are other easier ways to find HCF and LCM. Let's discuss that. So let's say we need to find the HCF and LCM of 24 and let's say and 40. So here let's common division method we can use. Let's divide 24 40 by common factors. So what are they? So both are divisible by 2, isn't it? So let's divide this by 2, so we get 12. So here when you divide 40 by 2, we get 20. Still they are divisible by 2. So 6 and 10, they are divisible by 2 still. 3 and 5. See now 3 and 5 can leave it. They are they don't have any. They are co-prime. 3 and 5 they don't have any common factors. Okay, so you can divide by any number actually. So you need not divide by prime factors, but they are not. They don't have any common factors. Then we can divide by. So we were supposed to divide by only prime numbers. So after this, actually divide by 3. Then one time is not divisible by 3. Write it as it is. So again now, so it's divisible. Let's divide by 5. It's not divisible by 5. Leave it here one time. So we keep divide till we get 1 as the all ones here at the end. Okay. So now let's find HCF and LCM. So now HCF of 24 and 40. So HCF is so product of all the numbers, so by which you are able to divide both the numbers. So both the numbers got divided by these two and these two, correct. So both numbers got divided. So therefore, so HCM is HCF is 2 into 2 into 2 equal to 8. Okay, LCM is, so all the numbers, product of all the numbers, this up to this is 8. So 8 into 3 into 5. So we get 120. So here HCF is 8 and LCM is 120. Okay, there is let's find the product of the numbers. See what are the numbers we have taken, 24 and 40. Okay, let's multiply 24 and 40 now. So 24 into 40 is equal to, so you will get 960. Okay. So now multiply the HCF and LCM. HCF into LCM. So again 8 into 120. So you get 960. See same. So product of, this is true for any two numbers. So for any two numbers, so HCF and HCF the numbers, the product of the numbers equal to product of their HCF and LCM. Okay, this is true for any two numbers. See, let's take see this one we have found here. Initially we found HCF and LCM of 4 and 6, correct. So what's 4 into 6? 24. What's HCF and LCM? HCF is 2, LCM is 12. See, 2 into 12, that's also 24, correct. So this is true for any two numbers. So product of two numbers is equal to product of their HCF and LCM. Okay, there is another way to find HCF and LCM. Okay, that's by using prime factorization. Okay, as I said, any number can be written as a product of prime factors. So let's suppose I want to find the HCF and LCM of 24 and 40. So find the prime factors of 24 and 40. So if you find prime factors of so if you write as a product of prime factors, 24 is what? You can use that as I said, you can use the division method to find that. So you will get so this is 8 into 3, so you will get 2 cube into 3, you will get say 24, say 2, okay, it's 12, 2, 6 times, 2 3 times, and 3 1, say 2 into 2 into 2 into 3. Okay, similarly what is the other number? 40. So 40, okay, so this is 8 into 5, so 2 power 3 into 5, this is what you will get if you prime factorize. Okay, now to find HCF. So what are the common prime factors here? 2 and 3 here. Sorry, common prime factor is only 2, because 2 is only common prime factor. 3 is not common. 3 is a prime factor of 24, but not 40. Similarly, 5 is a prime factor of 40, but not 24. So 2 is only common prime factor. So for HCF, you have to take the smallest power of 2. So what is the smallest here? Here 3, both are equal, so you just 2 power 3. So which is equal to 2 into 2 into 2 is equal to 8. Okay. For LCM, so we need to take, say if there are say common prime factor but different powers, so you need to take the highest power. See here, highest and lowest all same, all 2 power 3, and also you need to multiply by all other prime factors, so into 3 into 5, so you will get 120. Hope it's clear what I am discussing about. Okay, what I am saying, suppose we let's there are two numbers, let's say A and B. We need to find HCF and LCM A and B. Let's say when the prime factor is A, suppose we get say 2 power 3 or 2 power yeah, so 2 power 3 into 3 square, and B, so you get 2 power 5 into 3 into 5, let's say. Okay, now so this we have prime factorized. Now how to find HCF and LCM of A and B? So HCF of A and B is, as I said, see what are the common prime factors here? 2 and 3. So you need to take the least power of them and multiply. See here 2 power 3, 2 power 5. What is the smallest power? 2 power 3. So 2 power 3. Similarly here 3, smallest power is 3. 3 means just 3 power 1, no? 3 power 1. So just 3. So this is HCF. And LCM will be, you take the highest power in common factors. Whether common or not, you need to take the highest powers. So it's 2 power 5 into 3 square into 5. Because 5 is not common, still we need to multiply by that factor. So 2 power 5 into 3 square into 5. So here it will be 2 power 3 is 8 into 3, 24 here. So HCF is 24 and LCM is say 2 power 5 is 32, okay, into 9 into 5. So it is 1440. Is 160 into 9, yeah. So this is HCF and LCM. Okay, so if A and B are this, A is 2 cube into 3 square and B is 2 power 5 into 3 into 5, then HCF of A and B is 24 and LCM is 1440. Okay, hope it's clear. Thank you.